Lens shield working with sun simulators. A Physicist thoughts, dated November 18th, 2016. Let's proceed. In this article, I discussed the various lens shields that seem to be in operation in conjunction with various sun simulator devices, including the one that gives rise to the appearance of a sun halo around the sun. When I first thought about the sun halo, I thought it was an effect of the ionized iron issuing from a brown dwarf star accumulating around the sun. Then I saw that it was not seen all over the world at the same time, so it has to be a local effect. This type of local effect can only be produced by placing a lens shield in close Earth orbit whilst the sun simulator itself is farther away. The ionized iron accumulating around the sun is still happening, and the sun is obviously being drained of energy, but what I think now is a brown dwarf binary system and possibly another larger brown dwarf further away. I was led to the conclusion that a binary brown dwarf system was making loops around the sun by the last partial sun darkening episode on October 26, 2016. This came through analysis of images provided by the SDO satellite for that day. Figure 1 below shows an object that is obviously a source of light and therefore a star. Remember, planets do not emit light. They do not have the ability to have fusion on their surface. It is either a star that emits mainly red light or it is a very red sun. If it is our sun, this image would provide strong evidence of how weak it has become, i.e., it has become red instead of the bright white star it once was. Yeah, the sun. I have made mention in previous videos, I was strongly impressed that the sun was becoming a red giant. Now, I could be totally wrong, and I hope I am. It's just a thought, boos. Figure 1. Red star in the sky. If this star is our sun, it is a very weak sun. Figure 2. The petal lens flare arrangement around a sun simulation device. Figure 2 shows the many times observed the red petal images and lens flare arrangement around a sun simulation device. We can know that the bright light in the middle is due to a sun simulation device by observing that the outline contains straight lines and that the rays of light emanating from the center are symmetrical. This would be impossible if the source of light was a natural one. The red lens flares arranged in a symmetrical grid pattern around the sun simulator are indicative of the fact that there is a red light source behind this particular lens shield. You cannot get a red lens flare without there being a red source of light to produce it. It could be more than one, but we know that there must be at least one. What could this source of light be? There are several options. It could be a red star, even the sun itself, if the sun itself has become a source of mainly red light. It could be a red planet being illuminated by a star. If this is the case, this would be a planet, possibly a red giant, which absorbs all visible light frequencies and reflects the red frequency only. Number 3, it could be an artificial light source. I have thought before that it may be due to the hologram projector used to make sure that the simulated sun has the correct surface features for anyone with the solar telescope. This is therefore one of the possibilities. The reason why we see so many out of focus red light sources around the sun simulation device is likely to be due to that the lens shield is being used in combination with the sun simulation device. Figure 3 below shows a possible arrangement of such a device. Hexagonal frontal lenses, right? Each of the lenses refract the light coming from the red light source. Thus, we get primary images, which are brighter, and secondary images, which are less bright than the primary images. All the images would, however, need to be out of focus. The secondary images are what we call lens flares. Figure 3. hexagonal shaped frontal lens array positioned and attached to the sun simulation device. Hexagonal shaped frontal lens, sun simulator. The lens array in figure 3 is thought to be attached to the sun simulation device. There are many sun simulator designs in operation, and this is probably only one of them. The reason why the lens array needs to be attached is that if it was not attached but in front of the sun simulation device and closer to the earth than it, we would see several images of the sun as well as several images of the red light source. The lenses are likely to be a hexagonal because it is difficult to construct perfect circles, and also with hexagonal lenses it is possible to position the lens in an array without leaving any gaps. Number 4, the halo around the simulated sun produced by a lens shield between the sun simulator and the sun. Figure 4 shows the halo effect around the sun. Figure 5 shows another image of a halo where we can clearly see that the simulated sun is not at the center of the halo. This indicates that the halo is produced by a lens that is not attached to the sun simulator, but in front of the light source. The symmetric rays emanating from the light source are symmetric, indicating that it is an artificial light source, i.e. a sun simulator. Figure 5, again. Halo around a sun simulator is not centered on the sun simulator, indicating that the lens has to be in front of and not attached to the sun simulator device. Now, the rainbow type effect at the edge of the halo can be explained by chromatic aberration. I have explained this in another article, but I repeat it here. Figure 6 shows that light going through the outer edges of a lens focuses at different points for different frequencies of colors, giving rise to the separation of colors at the edges of the sun halo. Any object that would be seen close to the edge of the sun simulator would be unfocused and difficult to see. Parallel rays coming from the sun simulator lens, boom. Here you see your simulated image. Figure 6, a lens shield that only refracts light at the edges results in a sun and halo image. The halo occurs as a result of chromatic aberration. Figure 7 below illustrates how chromatic aberration occurs and therefore how it can lead to the appearance of an actual rainbow effect at the edges of the sun halo. Figure 7 on the left, illustration of the different frequencies or colors focusing at different points. On the right, the top image has no chromatic aberration effects, but the bottom image shows unfocused edges and color separation on the right-hand side of the roof. Figure 8 below shows a sun halo effect as well as the red petal arrangement, looking even larger and unfocused than usual. This is an indication that the sun simulator device and lens array combination is the actual light source in use here, and that the lens shield that produces the halo effect is between the sun simulator, illustrated in figure 3, and the earth. Notice that the sharp red lens flare that I usually associate with a holographic projector, which is another indication that the light source is artificial. Separation of colors is also clearly seen at the edge of the halo, which can be explained by chromatic aberration. Figure 8, artificial light source indicated by the sharp red lens flare and red petal arrangement around it seen here inside of a halo. This indicates the use of two lens shields, one attached to the sun simulator and another between it and the earth. Figure 9 shows another sun simulator and lens shield producing halo effect combination. The symmetric rays and the presence of the sharp red lens flare I associate to a holographic projector and indicate that the light source here is also artificial. The separation of colors at the edge of the halo indicates that a lens is being used that produces chromatic aberration. Figure 9. Image of effect produced with a lens shield device that produces a halo is placed in front of a sun simulator. Now, however, the rays of light that we see sometimes can be seen emanating from the center of the halo at the edges, and it may indicate that this type of shield may not just be a visible light shield, but an electromagnetic shield. as well. In other words, it may be able to actually reabsorb the radiation other than visible light radiation and even plasma discharges coming towards the Earth. Figure 10 below shows a halo around a sun-like light source, and we can also see what happens to be plasma discharges from around the center of the shield and its outer edge with light then emanating from the outer edge. Notice as well that the light source here looks square. It could be that the sun simulator device, or it could be that the shield has a collection point at the center where energy or plasma discharge energy is collected, and that this collection point is square in shape. This energy then discharges to the outer edges of the shield, producing the sundog effect seen here, figure 10. And I conclude, sun halo with the sundog effect that could be due to plasma discharges happening between the center of the shield and its outer edge. Chris Potter of Physicist Thoughts, December 28, 2016. Have a great day.